we're going to take a look at what a box and whiskers plot looks like. So what I like about it is it's a visual representation. I'm very visual, so it allows me to see the data on a number line, and I can look at the variation from that median. So what is a box and whiskers plot? It's a way to display data on a number line by organizing it into 4 sections. So here's how it gets its name. This is the box, and these are the whiskers that we're talking about. So it's box and whiskers. And so we need these values in order to make my box and whisker plot. And that's called the 5-number summary. So I'm going to start with the median because we know what that is. So the median, remember, it's your middle number. Middle number of the data. And remember, it has to be ordered from least to greatest. All of this has to be ordered from least to greatest. Okay, so we're going to start there. And then the minimum value is just the smallest amount. So then the maximum value is going to be the largest amount. And the lower quartile, that is your median of the lower half of your data. And so the upper quartile is still the median, but this is going to be of the upper half of your data. Okay, so that's how we get the plots. And then we're going to look at the quartiles. So the quartiles, you'll notice there's 4 sections, right? There's 4 sections in my graph. This part, so you have the minimum value, the maximum value. So this is 1/2 of the data. This is the other half of the data, and we're divided up into 4 parts. Okay, so the quartiles are going to be 4 sections that make up the box plot. 4 sections make up the box plot, and each section represents 25% of the data. And your interquartile range is just the range between lower quartile and upper quartile. Okay, so that's your interquartile range. Basically what it is, it's the length of the box, right? Okay, so let's take a look at this section here. The first part, because we're dealing with median, is we have to number our data from least to greatest. Okay, and that's probably the hardest part, is ordering that data from least to greatest, making sure you don't miss a plot. So I got a 50, I have a 55, I have a 58. When I start with 60s, I have a 62, I have a 64, I have a 68.
Attention. This is life safety, and we wanted to tell you that we do have lightning in the area.
A 72.
Please stay inside.
I missed a 60.
Again, there is lightning in the area. Please stay inside.
I missed a 60.
Thank you.
Okay, so then I got 72, 76, 84, and a 92. So it's kind of nice that you saw me miss one. I caught it, and I would have caught it at the end when I counted them. So I'm just going to rewrite them real quick. 60, 62. Mistakes happen all the time in writing the data. All right, so the first point I'm going to make is I'm going to find the median. So how many data points do we have? We have 4, 8, 9, 10, 11, 12. So 6 is going to be on one side, and 6 is going to be on the other side. So remember how you get the median is you add them up and you divide by 2. So if you add these up and divide by 2, you're going to get 66 is the median. Okay? Now, remember what you have to do here. So this is the median, and I get 66. Now you've got to find the median of your lower data, and that's going to be the lower quartile. So here, smack dab in the middle, right? So 58 and 60 divided by 2 is going to be a 59. So 59 is going to be your lower quartile. And then over here, your upper quartile is going to be between 72 and 76, which would give you a 74. So 74 is going to be your upper quartile. Your minimum value is this 50, and then your maximum value is going to be 92. Okay, so let's take a look at how I'm going to arrange that on my plot here. So I'm going to get 66, and then I'm going to go by 5. So I'm going to go 65, 70, 75, 80, 85, 90, 95. I'm going to go 60, 55, 50, 45, 40, and 35. And I probably could have started a little further over here to 50. All right, so 66 is right here, so this is going to be my median. My lower quartile is going to be 59, and my upper quartile is going to be 74. So my box, remember, is right here. It's the lower quartile to the upper quartile, and then my lowest points of 50, and my greatest points of 92, and then that's how I make my whiskers. Okay, so that's what my box plot looks like. Now let's get to the questions. Remember, each of these quartiles represents 25% of the population. So the range is just my greatest point to my least point. So the range is going to be 42. What is the interquartile range? The interquartile range, remember, is from your lower and upper. So 74 minus 59 is going to be my lower, which is 15. And how did I get it? I did 74 minus 59, so that's 15. Now, look at what this says. It says, what percent have a resting heart rate less than 66? This much is less than 66. That's 50% of your population. So 50% of your population have a resting heart rate less than 66. What percent have a resting heart rate of no more than 74? So 74 is here. What has a resting heart rate no more of 74? That's going to be this set of the population, which is 75% of the population. Okay? Now, as we scroll up, I'm still going to keep my data there. What percent have a resting heart rate between 50 and 59? 25%, because that's one of your quartiles. So 25% have a resting heart rate between 50 and 59. And what percent have a resting heart rate between 66 and 92? That's 50% of your population. So each of those quartiles represents 25% of the population. And so we read it from there. All right, let's take a look at the next page and do, okay, I think you kind of understand probably about how to draw it. I really want to look at the data here. Okay, so I really want to look at analyzing it and what that means. So what is the median score? The median score is an 80. What percent of the students scored between a 70 and an 85? That's 2 quartiles. That's 50% of the population. So, and this is a test scores for a group of 24 students. So this is what the data looks like. Test scores for 24 students. So 50 of them, 12 of them scored between a 70 and an 85, right? All right, and how many students scored between 45 and 85? Well, if that's 75% of your population, then you would do 75 over 100, and there's a total of 24 students. So what would be 75% of 24 students? And again, you could set a proportion and cross multiply and then divide by 100. So 18 students scored between a 45 to an 85 because that's 75% of your population. So 75% of 24. That's how I get my answer there. You don't have to do a proportion. You could just do, 0.75 times 24, and that's also going to give you 18. Okay, so if Kate got an 87, how did she do compared to the class? She did great. She scored in the upper quartile. So Kate would place, she did well. She placed in the top 25% of her class. And so she was in that upper quartile. So she scored better than 75% of the students in her class. All right? Let's take a look at the other next page. And then I just want to go over what these mean. So fuel efficiency in miles per gallon of a group of cars is shown below. What is the interquartile range? Remember, here's your interquartile range, 20 to 30. So 10 is your interquartile range. What percentage of the cars have a fuel efficiency greater than 20? This represents greater than 20, so that's 75% of cars have a fuel efficiency greater than 20 miles per gallon. And what percent of the cars have a fuel efficiency less than 26? Less than 26 would be 50% of the population because it's 2 quartiles. Each quartile is 25%. All right? Now, look at don't know how that happened. Look at number 7. The battery life in hours of a group of 16 laptops, so 16 laptops, and here's the data points. Identify the lower and upper quartiles. So 3.5 is the lower quartile, and 6 is the upper quartile. So lower quartile is 3.5, upper quartile is 6. What percent of the laptops have a battery life of at least 6 hours? So 6 and above is 25% have a battery life of at least 6 hours. And then how many laptops have a battery life less than 4.5? Well, that's 50% of the population. There are only 16 laptops. So half of 16 is 8. 8 laptops have a battery life less than 4.5. Okay, let's take a look at number 8. We got 50 golfers competing in a golf tournament, and the scores in the first round are shown below. Identify the minimum and maximum values. So the minimum is 68, and the maximum is 79. What percentage of the golfers had a score greater than 70? These all guys had a score greater than 70. So 25%, 25%, and 25%. 75% had a score greater than 70. Okay, in order to advance to the next round, golfers cannot score above a 72. How many are not moving on? 25% of the 50 golfers are not moving on. So 25% of the 50 golfers, so 1/4 of the 50 golfers are not moving on. So 1/4 of 50 is going to be 13 golfers are not moving on. Okay, so if we're looking at comparing, what is the difference in the median score? Well, Athens' median score is an 80, and Gilman's is a 75. So the difference in the median is a difference of 5 points. Which class had the greater range of scores? Mr. Athens went from a 45 to 100, so Mr. Athens had the greatest range. But what class do you feel did better overall? Well, looking at it, you would think, oh, well, his median is an 80, and they got 100. And so 50% of the population scored above an 80, and then 50% of the students scored above a 75 to a 95. Okay, so when you look at it, it looks like Mr. Athens' class may have scored better, but when we take in the numbers, when we're looking at this, their minimum score, Gilman's minimum score was a 60, where Mr. Athens had a score of 45. And so Mr. Athens' class only had 75% score greater than 60. But Mr. Gilliam's 75% scored greater than 70. So I would argue that Mr. Gilman's class had the better score because 75% of his students are scoring above a 70, whereas 75% of Athens' class is scoring above a 60. So I would argue that Gilman's class is, but if you have a better argument, you could argue against me as well. Okay, so that's your box and whiskers plot. If you're struggling with that, come and see me.